Research and Program Evaluation, CPCE Survival Guide. The Research Design Squad. Think of experimental research as a cooking competition where you actually control the ingredients. You're testing whether your special sauce, independent variable, really makes the dish better, dependent variable. You need two groups. One gets your fancy treatment, one gets plain old ketchup, control group. The key, they need to be similar except for what you're testing, like having two identical kitchens. The variable family tree. Independent variable, the puppet master, what you manipulate, the treatment, intervention, or special sauce. Dependent variable, the puppet, what changes because of your manipulation, the outcome you measure. Organismic variable, the DNA you can't change, age, sex, height, eye color. You can't randomly assign someone to be 6'2" or make them 45 years old for your study. Hypothesis headquarters, the three amigos. 1. Directional/alternative hypothesis, the confident predictor. There is a significant difference between these variables. Takes a stand, picks a side, has an opinion. Example, CBT will reduce anxiety more than no treatment. 2. Null hypothesis, the party pooper. Nope, no significant relationship or difference here. What you're trying to disprove. Statistics love to reject this guy. 3. Nondirectional hypothesis, the diplomatic one. There's some difference, but I'm not saying which direction. Playing it safe. Type 1 and Type 2 errors, the tragic comedy. Type 1 error, rejecting the null when it's actually true. Think, false alarm, crying wolf. You say there's a difference when there really isn't. Alpha. Level controls this, usually set at 0.05. Type 2 error, failing to reject a null that's actually false. Think, missed opportunity, walked past a $100 bill, you say there's no difference when there actually is. Beta risk. Memory trick. Type 1 is being Type A personality, overreacting and seeing things that aren't there. Statistical superstars. Correlation coefficient, the relationship matchmaker. Ranges from -1 to +1. Measures strength and direction of linear relationships. Doesn't mean causation. Ice cream sales correlate with drowning deaths, but ice cream doesn't cause drowning. Both increase in the summer. Level of significance. Alpha, the bouncer at the club. Determines probability threshold for accepting results as real versus chance, usually 0.5, 5%, or 0.1, 1%. Lower equals stricter standards. Bivariate versus multivariate, size matters. Bivariate, two variables doing the tango. Multivariate, the whole dance floor, 3+ variables getting funky together. CPCE style practice question. A researcher wants to test whether a new anger management program reduces aggressive behaviors in adolescents. She randomly assigns 30 teens to either the treatment group receiving the program or control group receiving no treatment. Then measures aggressive incidents over 6 weeks. The aggressive behaviors being measured represent A, the independent variable being manipulated by the researcher, B, the dependent variable that may be influenced by the treatment, C, an orgasmic variable that cannot be controlled in the study, B, the aggressive behaviors are the outcome being measured, dependent variable. The independent variable is whether they got the treatment or not. Orgasmic variables would be things like the teen's age or gender that can't be manipulated. Rothenthal's Purple Book Wisdom. Remember that experimental research requires random assignment and manipulation of variables. This is the gold standard. Correlation studies can't establish causation, no matter how strong the relationship is. And always watch for confounding variables lurking in the shadows.